Now in example one, let's just kind of wrap our brains around this here. We're going to be talking about a car in this example, but since a lot of high school students and junior high students or middle school students don't drive, another way you could think of this is think of some items that when you buy them, they're never going to get more valuable. They might personally get more valuable as you use them, but it just is in terms of money, they don't. I'm kind of thinking of computers, tablets, iPads. Those for sure. I guess the worry is that people think they're going to get slowly get worth less money, especially if new things come out. Cars are the same way. If you take a car, purchase it, a lot of people say this is the moment you drive it off the lot, it's not worth anything or not worth as much anymore. So this car we're going to start with is $20,000, but we've got to expect that it's going to depreciate at some rate. The rate they're going to use here is 25%. Now think about that. That's 0.25. Okay. What we're going to do is write a decay model to represent this, and then we're going to find out how much it's worth after 5 years. So let's start here. We're going to let y be the value of the car after those 5 years. T is going to be the number of years, which we said is 5. The initial value that we're using here is 20,000. So we can put 20,000 right there. The decay rate that we're talking about is 25%, but for our mathematical purposes, we need to use 0.25. For one thing, and actually this is the biggest thing, is it makes it easier to put in a calculator. Our formula looks like this. That y value is going to be this. C times this stuff right here, 1 minus r, raised to the t power. And I'm going to say this again. T only applies to this, the 1 minus r. So let's put the 20,000 right here. That's where we're starting. And we're going to take away 1 minus 0.25 raised to the t. So we've done the substitution here. You don't have to write the stuff over here. We've done the substitution on this side. Here's our model. 20,000. And then you've got to do 1 minus 0.25. Now a whole minus 0.25 is 0.75. And we're going to raise this to the t, which is the time. For 5 years, we're going to substitute 5 for t. So now it looks like this. 20,000 raised to the 0.75, I'm sorry, times 0.75 raised to the t. And that's, I think we'll save a little space here. Let's just put a 5 over that, because that's really what we're doing. Now, when you do this in your calculator, here's what you have to do. Make sure that you're, I would say really do this first. Whoops. Do this thing first, because order of operations tells us to do that first. So we're going to take 0.75, we're going to raise it to the 5 power, and we get 0.2373. Do that in your calculator. But that's not the value of the car. It's not 23 cents. We still have to multiply it by that 20,000 original value, and it comes to 4,000, and we'll round this off to the nearest dollar. It's 4,746 after 5 years.